How do we find the acceleration experienced by objects in free fall? We know free fall means they're only moving under the influence of gravity, so the acceleration should be negative 9.8 meters per second squared. However, as some of you saw while we were outside at the band tower, there were other factors like wind, which helped increase the air resistance, and if your egg carrier wasn't particularly dense or aerodynamic, that air resistance could have more of an effect than some others. So we're going to do a practice problem to figure out how to determine that acceleration your egg carrier experienced. So the example problem I'm going to use is it took an egg carrier 2.34 seconds to reach the ground after being dropped from a height of 20 meters. Please note that your eggs did not fall 20 meters. They started at the band tower, which is approximately 8 meters high. What acceleration did the egg carrier experience? So asked, given, identifying the equation, and solve. So here it says, what acceleration? So I'm being asked for a acceleration. What information am I given? Well, I know it fell 20 meters, so we can say it started from its origin, so the initial position. Remember, if not given, we assume it's 0. And then the final position is negative 20 meters. We also know the time is 2.34 seconds, and we dropped the egg. Dropped means our initial velocity is 0 meters per second. So I see in my equation initial and final position, or in my given, the initial and final position. So the equation I'm going to use is xf equals the initial position plus the initial velocity times time plus 1/2 at squared. Remember, when we have the equation with g, that just means we know little g is Earth's gravity. I'm using a here because I don't know if that's true. I'm going to see if air resistance affected my egg or not. Before I solve, I'm going to look for anything I can cancel out, anything that's 0, like my initial position and my initial velocity, and anything times 0 is 0. So the equation we are solving with ends up being this one, 1/2 at squared. I'm looking for a, so I'm going to do some rearranging of my equation. I'm going to start by multiplying both sides by 2 to cancel the 1/2. So I have 2 times the final position equals at squared. I'm looking for a, and a is multiplied to t, so to undo that multiplication, I'm going to divide both sides by t squared. The squared is attached to the t, so I have to take it with the t. So this cancels. So we're left with 2 times the final position divided by time squared. That's going to be equal to our acceleration. And now we're ready to plug in our given values. So it's 2 times the final position is negative 20, because we ended lower than we started, divided by t squared. T is 2.34 squared, and that's going to equal my acceleration. So I'm going to plug this in on the calculator. We know 2 times negative 20 should give us negative 40, and it does, divided by 2.34 squared. And that's going to give me a negative 7.31 meters per second squared as the acceleration. So did my egg in this example achieve free fall? If you're thinking no, you are correct. If my egg was truly in free fall, we would have gotten an acceleration equal to that of gravity, negative 9.8 meters per second squared. Since we didn't, we know there was some sort of outside force other than just gravity that was acting on my egg carrier.